Hi, my name is Gopal and my team ID is 1389793. My project is about smart farming using TI, which is a fully automation of agriculture project. Here I am going to discuss about the technical video or technical intermediate video 3, which is the final technical discussion of our this IICDC 2019. So I like to give some short introduction about our project. Our project is a fully automation of agriculture project where every task of the agriculture is fully customized and automated. In this automation of agriculture project, the main theme of the project is to detect the soil health of the agricultural land. That is, it consists of macronutrition and micronutrition. Through this project, we can able to detect the macronutrition, which is most essential for the efficient growth of the plants. So next, it is completely the data is visible to the farmers through the app called HAR. The HAR app does not only monitor the soil health; it also acts as a marketing, and it can also sell their products to the customers or clients what they have. So the farmers also can able to rent their tractors or farming equipments from the sellers. It is like an common open source sector. So everything is monetized, and we can able to store digital green card for the farmers in our app. So this is the short introduction of our project. Then we will just move to our uniqueness of the product and prototype of the product. It will be just continuing the next sectors, next stages. So let's move on. Hi, this is Gopal, and I'm here to explain about the flowchart, the workflow of our project Smart Farming using TI. So in this project, we use the main three components. One is the microprocessor, and next is the microcontroller, and all the sensors. So we use BeagleBone as the main microprocessor. So because it is the heart of our project. BeagleBone is the one of the product of Texas Instruments. So I use BeagleBone as a main processor, from which all the data we receive from the sensors and microcontrollers will be sent to the server. So from server we will be taking these readings to our app and website. So next comes to our microcontroller. We use Butkani as a microcontroller, which is a Texas Instruments microcontroller. From microcontroller, it is a microcontroller inbuilt with Wi-Fi. So we use I2C lines to connect with all the sensors like HDC2080 EVM. Next is temperature and humidity sensor, then NPK sensors and pH sensors. So all the sensors are connected with the microcontroller, and the microcontroller is connected to the microprocessor to send these values to the server for consolidating the health of the soil. So then we come to our applications. So we have a Android application that is called HAR, and a website called har.ml, which has been hosted. So I will just show the video of our website after finishing the prototype, that is after the prototype structure. So in that application, farmer has to log in and register. So after the login and register, they can able to use that app with their own logins. So it is completely secured. We use HTTPS SSL certifications for our security of data, that is the personal data like Aadhaar number and agriculture, that is green card numbers, so etc. Everything is stored digitally in this app, and this app contains the health of the soil, that is the health related data of the soil, that is the values of the temperature, humidity, NPK values and pH values. So based on that, we have some certain formulas to calculate the health of the soil. If these amounts are to up to the level, we can able to say that your soil condition is well and good, and you can able to use enough amount of you don't want to use enough fertilizer. So everything is actually it is okay for the soil to cultivate more crops. Next comes to our irrigation purpose. So for irrigation purpose, we have connected the same microcontroller to the motor, that is the pumping motor, which supplies the water from the well to the other parts of the soil. So from the microcontroller, it is also these values also connected to the processor, so that we can able to control our motor from our application, that is the switching on and off of the motor. We have two modes, that is the water supply mode and the normal mode and the manual mode. So normal mode means it is just usual water usage to the agriculture land, and if water saving mode means it will consume only less amount of water than the normal mode. Then is the manual mode is we can able to switch on and off by ourselves, so it is everything depends upon the farmer's decision. So next comes our rental, that is rental part. We can able to rent the farming equipments like tractors, the yielding machineries, and farming equipments can be pesticides, fertilizers. Pesticides cannot be rented, we can able to buy. So we can able to rent those tractors and farming equipments in this app itself. So we connect these app to all the vendors, and that will be displayed to everyone, to every farmers who are using this app. Next comes to our news part. So news part contains the latest technology and the agriculture methods which are implemented by our Indian government, and it is completely tested for good yield of crops. So next comes to our marketing part. So marketing part is like selling their own products. If a farmer cultivates tomato, means they can able to sell all these tomato to the companies, that is the food manufacturing companies or the clients, like we people. So they can able to sell directly to the peoples without intervention of the third parties. So it is completely the direct contact between the what the farmers and the clients, or the farmers and the companies, food companies, like we say, I don't like to mention these companies. So it is also helpful for many of this marketing purpose also. So that's all about this app. So it has every features like a farmer needs. These data are completely stored, and it is able to add as a resource for another persons who are using our device as a agri health detector. So it is completely useful for others. So these resources are completely saved in the server and used for future purposes. So next our friend Suhas will be continuing about the prototype video. So next we will just move on to our prototype. This prototype, since due to COVID we can't able to flourish fully, so but we have implemented as far as we know. So just we will see. Okay, thank you.
Hi, myself Suhas and I'm taking care of electronics side. Let's talk about the main purpose of doing this project. If you go for IoT projects in agriculture field, it's very minimum and it's costly too. We team initialize a step to drop the IoT system in agriculture field with an affordable price. Let's talk about the working of our project. In agriculture based project, the first step is to get the nutrition level of the soil and also get the acidity level of the soil. To get the nutrition information, we are using NPK sensor. This sensor will get the basic information from the soil like nitrogen, potassium and phosphorus content. And to get the acidic value from the soil, we are using pH sensor. Like the soil may expose to more pesticides. Because of the pesticides, the soil acidic level may be increased. Let's talk about the brain of the process, which is basically a controller. The controller reads the sensor value and compute the data, get the average of it to minimize the error. And for the further process, it regulates the motor driver. And also another question may rise, why we are using microprocessor? If farmer have large area of land and we need to compute all the data, we can have a multiple controllers over the large area, and from the multiple microcontrollers the signals are gained by the microprocessor, and all the microcontrollers may be controlled by the microprocessor, and microprocessor compute the data and send to the cloud. For the microcontroller, we are using CC3200, which is a Texas based controller. And for the pH sensor, we are using PH4502C. And controlling the motor, we are using DRV8848 motor driver. And for the temperature and humidity, we are using HDC2080 EVM. For the prototype, we are used USB supply. For the portability, we are using lithium cells. To charge these lithium cells, we are using battery boost pack. Okay, I have covered major hardware area of our project, and thanks to Texas for giving this opportunity to explore our talents.